Hi everyone, my name is Madam Rosmaya. So in this video, I'm going to discuss on the topic root mean square values, or another word in short form we can say RMS values. So what is meant by RMS values? The RMS value of an alternating current is the value of the direct current that dissipates heat at the same rate as the mean power dissipated when the alternate current flows in the resistor. Example, in this two simple circuit consists of bulb and the supply from the direct current, and another one is from the alternate current, and both bulbs used here is identical. Okay, consider that both the bulbs are giving out equal level of brightness, so they are losing the same amount of heat regardless the fact of AC or DC. In order to relate both, we have nothing to use better than the RMS value. So if in the first circuit for direct current we use 12 volt, so the second circuit we use 12 RMS volt. Okay, why use RMS values instead of average values? Okay, for direct current, the voltage and also the current is always constant. But in the alternate current, the voltage and the current values always changing. Attempts to find an average value of AC would directly provide you the answer 0. Hence, RMS values are used. What does root mean square really mean? Okay, in mathematics, the formula for RMS is equals to the square root of x1 squared plus x2 squared plus x3 squared plus xn squared divided by n values. Okay, first you square all the values, then find the average of these square values over a complete cycle, and finally find the square root of this average. So we are going to discuss in the physics concept for the alternate current. The instantaneous power dissipated from the resistor is given by instantaneous power equals to I squared R. So mean power means mean value of I squared R. So which means I1 squared plus I2 squared plus I3 squared plus divided by the number of cycles. Okay, R is constant, so therefore the mean value is same as R. So leaving only mean value of I squared. So now we are going to relate with the previous slide for mean value of I squared with the IRMS. So IRMS squared equals to mean value of I squared. So therefore IRMS is equals to square root of the mean value of I squared, which means I1 squared plus I2 squared plus divided by n values. So now we rearrange this, write as IRMS squared times R. So this is the mean power. Okay, this is the first step to determine the relationship between RMS and the peak values. The second step, we use same equation, mean power equals to mean value of I squared R. So mean value of I squared, we use I naught sine omega t squared. Next, expand the bracket. So we get mean value I naught squared sine squared omega t R. and then bring R inside the bracket. So we have mean value I naught squared R sine squared omega t. I naught squared R is constant, so we can bring out to the front here, leaving mean value sine squared omega t. And using trigo identities here, cos 2 theta equals to 1 minus 2 sine squared theta, and then sine squared theta equals to half bracket 1 minus cos 2 theta. So we rewrite this as sine squared omega t equals to half bracket 1 minus cos 2 omega t. And omega is 2 pi f, so we substitute into omega, we have cos 4 pi ft. So the mean value of cos 4 pi ft equals to 0. So we just use the maths rule here. So we don't have to discuss in detail how we get this. And because of 0 and the mean value half times 1, this one is a constant. So therefore we get half I naught squared R. So this is the second step. We get mean power half I naught squared R. Okay, now compare these two equations. So equate them. Cancel out R. So we have half I naught squared equals to IRMS squared. Square root both sides. And we get I naught per square root of 2 equals to IRMS. So just rearrange this. IRMS equals to I naught sub 2. So this is the relationship between RMS and peak values for current. Okay, for voltage, next we are going to do for voltage. So we use the same equation. We are going to use V equals to IR to relate with IRMS. So if we use V peak equals to I peak R, so for V peak, I also must use I peak. I peaks means the maximum current. So rearrange this equation, become I naught equals to V naught per R, or I peak equals to V peak per R. So VRMS equals to IRMS R. So therefore IRMS equals to VRMS R. So we substitute into the equation here, I naught or I peak equals to V peak per R, and then IRMS equals to VRMS per R. Okay, cancel out R. So we get VRMS equals to V peak per sub 2. Now we've done for both relationship between RMS and peak values for current and for voltage. So we try one example. An AC is given by I equals to 8 sine 20 pi t, where I is in ampere. Find the peak value of the AC. Next, the RMS value of the AC. And lastly, the frequency of the AC. So for question A, general equation of I is I naught sine omega t, and omega is 2 pi f. Compare with the equation given in the question. So from here, I naught is 8. I naught is I peak. So the peak value of AC, I peak is equals to 8 ampere. Okay, next for B question, find the RMS value of the AC. So we use IRMS equals to I peak per sub 2. Okay, substitute I peak 8 ampere into the equation. So we get 5.66 ampere. So this is the RMS value for alternate current. IRMS equals to 5.66 ampere. And next, the frequency of the AC. Okay, again we compare the general equation I equals to I naught sine 2 pi ft with the equation given 2 pi ft equals to 20 pi t. So t cancel out, pi also cancel out. So we get frequency equals to 20 per 2. So the answer is 10 Hz. Frequency of the AC. Okay, that's all. The end.